In section 2.5, we're going to talk about various measures of position and how they describe the spread of the data. Our objectives include finding quartiles and the 5-number summary, calculating the interquartile range and detecting potential outliers, drawing box plots, comparing distributions, and calculating z-scores. We hear percentiles discussed a lot in society, especially when you're talking about test scores. So let's suppose you had a test score of 1200, and if you did, you would be fortunate because 90% of the people would have test scores below yours, and only 10% would have test scores above yours. The word quartiles is much less commonly known than percentiles, but the two are actually very similar. Whereas you have percentiles describing 100% of the data and thus breaking it into 100 little pieces, quartiles will actually break the data into quarters or fourths. And in order to break the data into fourths, you actually only need 3 slices to do that. So Q1, Q2, and Q3 are called the quartiles because they are the marks that break our whole data set into fourths. And in order to find Q1, Q2, and Q3, we first arrange the data in order from least to greatest, just like we were finding the median. And in fact, the median is our Q2, the first quartile that we'll find. So ordering the data from least to greatest, the number in the exact center is Q2, and then we can find Q1 and Q3 by throwing out Q2 if Q2 is actually part of the data set, and then looking at the first half of the data set and the second half of the data set. Q1 is the median of the first half of the data set, and Q2 is the median of the second half of the data set. So here we have a data set that has conveniently already been ordered from least to greatest for us. And then to find the median, we choose the exact middle of the data set because we'll have 50% of the data that's below and 50% of the data that's above this median. And then we throw out the median when we're looking for Q1 and Q3, and so then we're left with these 12 values, and we want to find the center of those, that's Q1. Well, the center occurs right between 6 and 7, so we average 6 and 7 to get our Q1. And then here, the second half of the data set also has 12 values, and so the center falls right between 19 and 20, our 19th and 20th values, and so we average those values to get Q3. Calculating interquartile range, well, we already know what the range is. The range tells the spread of the entire data set, and it measures the distance between the maximum data value and the minimum data value. So then what would the interquartile range be? Well, inter means within, so within our quartiles. So the interquartile range is the range that is within the quartiles. So it makes sense that we are really just looking at the range between Q1 and Q3 for our interquartile range, and then we can calculate the interquartile range by subtracting the two, Q3 minus Q1. Here we have criteria for identifying an outlier. If we go from Q3 and in the positive direction we move 1.5 interquartile range units above Q3, then this area is the area where data values will be potential outliers. Also, if we go to Q1 and we went 1.5 interquartile units away from Q1, below Q1, that would also be the range for potential outliers if we had a data value out here. The 5-number summary summarizes the spread of the entire data set. We start with the minimum value of the data set, and then our next value is Q1, and then Q2, Q3, and then we have the maximum value of the entire data set. So these 5 numbers tell us how the data is spread out, because we know that 25% of our data is between the minimum and Q1, Q1 and Q2, Q2 and Q3, Q3 and Q4. And then if we know the 5-number summary already, it's pretty easy to get the box plot from that. You first need a scale that gives the spread of your entire data set, and then your first step will be to draw the box. the box will go from Q1 to Q3, and then it will have a line in there for Q2. And then you'll need to do whiskers from your box, and the whiskers will go from Q3 out to the maximum value that's not a potential outlier, and then from Q1 out to the minimum value that's not a potential outlier, and then we mark any outlying values, any outliers, with either asterisks or plus signs. Box plots can help us compare the spread of two different distributions. Even though box plots don't tell us as much information as a histogram would, they do tell us enough to make some good comparisons. Here we have a chart of gender and height. So we have two separate box plots, one for males and one for females, each showing their respective heights. And if we look at the average male height and the average female height, we can see that there's quite a bit of difference between the two. Even looking at the average male height, we see that very few females will ever be as tall as the average man. But still, you do have some overlap, so there are certainly some women who are taller than some men. We can also notice that if we look at the spread of all of the data values except for the outliers for men, and we look at the spread of all of the data values except for the outliers of women, you've got approximately the same range there going on. And you'll also notice that women tend to have more outliers than the men do. And I would fall approximately right there on the tail end before the outliers begin, so yay, I'm not an outlier. The z-score doesn't tell us the spread of the actual data set. It's not that sort of measure, but it does measure for one particular data value how far that data value is from the mean in terms of the spread of the data set. So it actually measures in terms of standard deviation. So the z-score is how many standard deviations you are above the mean if it's a positive z-score and below the mean if it's a negative z-score. And then if the z is less than -3, so if you've got -4, -5, so on and so forth, you've got a potential outlier. Also, if your z-score is higher than 3, so 3.01, 3.7, 5, those are all potential outliers as well. So thinking back to the previous example, if we're going to use this formula, and it's the observation data value minus the mean of all of the data values divided by the standard deviation, if we're to use this formula on the previous example, we'll have to do some guessing because we're not actually told what the mean or the standard deviation is. It looked like the mean for women was 66 inches in height, and then the standard deviation, I'm really guessing on this, but maybe approximately 2 inches of standard deviation, and then my height would actually be 62.5. I have to add that 5 because I'm so short. And then we do the minus, so 62.5 minus 66 divided by 2. Be sure if you're doing this problem in your calculator that you put parentheses around the numerator, and that will tell your calculator, hey, do this subtraction first, because else your calculator just won't know, and it will definitely do the division first, and you'll get the answer wrong. So 62.5 minus 66 divided by 2, that's going to give me -1.75. And so I can say that I am -1.75 standard deviation, so 1 3/4 standard deviations below the average height of women. But I'm still not more than 3 standard deviations below, so I'm still not an outlier, yay.